All right, we have Jose leaving and driving south at 35 miles an hour, so I'll call him J, and I'll say DJ dt is 35. And then we have Adrian, who's 2 miles east. Oops, I guess I'm making him 2 miles west. All right, so there's Adrian, and he's driving at 45 miles an hour. All right, so how fast is, so this is the 2 miles. So how fast is the distance between them changing? So I'm going to transpose, put J and A together, and then I'm going to put the 2 miles down here, and I'm going to find the rate the distance between them is changing here. So my equation will be c squared equal a plus j squared plus 2 squared. So then I'll take the derivative, 2c dc dt equaling 2 a plus j, and then I'm moving in to take the derivative, so I get dA dt plus dj dt, and the derivative of 4 is 0. I forgot to write down the when. So when they've been traveling for 2 hours, so when t equal 2, and now I'm ready to use the information to plug it in. So let's see, I can cancel the 2's. So let's use that when t equals 2, so then I can find out that A will equal 70 and J will equal 90, and so then I can figure out the third side of the triangle. So I get 70 plus 90 squared plus 2 squared is equal to c squared, and so that will tell me what c is equal to. So dc dt, so I'll have a plus j, so that's 70 plus 90, dA dt 45, dj dt 35 over the square root of 160 squared plus 4. And that's a great answer. All right, so now moving to speeding up and slowing down. So what are the two graphs that I need? I need v of t and a of t. Okay, so velocity will be the derivative, so 6t minus 3t squared. So to figure out what that is, I'm going to factor out a 3t, so I get 2 minus t. It's an upside down parabola because it's got the negative, right? Crosses at 0 and 2. So that's my v of t graph. A of t is the next derivative, so I get 6 minus 6t. So that's a line crossing at 6 on the y-axis, right? And 1 here. Okay, so when it's speeding up is when they both have the same sign, and they're slowing down is when they're opposite signs. So between 0 and 1, they're both positive. So between 0 and 1, they're speeding up. And between 1 and 2, this one's positive and this one's negative, so slowing down. And then after 2, they're both negative. So, oops, 2 to 4, they're speeding up again. They're both negative. All right, here, before I took a derivative, I would take the time to rewrite this. This is times pi x to the negative 1, reminding myself product rule, reminding myself how to take the derivative. I would pull the 1/3 power in front, so it's one less step to take the derivative. All right, so let's go do it. So product rule first, d second, ln of 3, and now take the derivative of this inside function, so I get negative pi x to the negative 2 plus 3 pi over x. Then I move on to the ln term, carry the constant of 1/3, 1 over stuff, and then moving in to take the derivative of stuff, 1 over the square root of 1 minus the argument squared, so e to the x squared, times the derivative of e to the x, which is e to the x. Okay, percentage error in volume means I want to find dv over v and then write it as a percent. So volume, you know, is 4/3 pi r cubed. So then I'm going to take the derivative of that in the numerator. So I get 3r squared dr. Remember, lots of canceling will happen here. So I'll get 3 dr over r. I put in what the radius is measured as, that's 3. And then the dr is 0.02, so I get an answer of 0.02. So as a percentage, that means 2%. So here, just more derivative fun. So taking the derivative, I get velocity. So the derivative of this term would be e to the t over 3 times a 1/3, plus the derivative of the next term would just give me a 1 over 30. Carry along the 3. Take the derivative of the sine, I get cosine. Carry the angle, and take the derivative of this angle, and I get times pi minus 1. So now I take and plug in t equals 0, so I get 1/3 plus 1 over 30. And cosine of 0 I know is 1, so I just get a 3 times a pi minus 1. This here you need log diff. So you have to take the ln of both sides. So ln of tangent of x all to the e to the negative x. So then I bring the e to the negative x down in the front. Now I'm ready to take the derivative. So on the left side it's implicit differentiation. On the right side it is product rule. So I get first d second plus second d first, and then to finish it off you multiply through by y, which is the original function tangent of x times to the power of e to the negative x. So I just have to carry all of this along, minus e to the negative x. I'm just going to write this in the front, and make sure you put the parentheses in. Okay, so I have volume of a conical pile, so that's 1/3 pi r squared h. They're telling me it's following this amount, cubic feet per second, so that tells me that's volume. And they want me to find how fast the height is changing, find dh dt, and when h is 6. Okay, so I see all the variables that I have, v and h, I have in my given and find rates. I don't have anything about r, but they give me information. The diameter is 4 times the height. It's 4 times the height, so I know that has to do with radius. So radius is 2h. So I need to get rid of r with that information first. So take and replace r with 2h, and then fix it first. So I get 4h squared, so 1/3 pi 4h cubed. Now I'm ready to take the derivative. So dv dt will equal 4 pi over 3 times 3h squared dh dt, and plug all the information in. So 15, 4 pi, and 6 squared dh dt. So 15 over 4 pi times 36 is dh over dt. Alright, so mean value theorem can be applied because this function is continuous on 1/3 and it is differentiable on 1/3. Okay, so what I'm looking for is the derivative. So that's 1 over 6x times 6 equaling f of 3 minus f of 1 all over 3 minus 1. So this left-hand side turns into 1 over x equaling ln of 18 minus ln of 3 all over 2. So I can cross multiply. So that gives me x is equal to 2 over ln of 6, because you know ln of 18 minus ln of 3, you can do division.